All right, so this is the homework with circuits. It's from the physics classroom. A couple things. I will shrink this down so you can see a whole page at a time, maybe. So you might be able to make it bigger or smaller if you need to. So 2, 9, 10, 11, 18, 20, 21 on this page. 25, 29, 30 on this page. And 32 on this page. So if you need to pause and look at that, absolutely go ahead. All right, now I'm going to make it large again so I can go through some parts of each of these. All right, for number 2, it was asking about how many coulombs pass through when you've got Anita Breeze's window air conditioner drawing 11 amps of current for 8 hours. So 11 amps you should understand is 11 coulombs per second. And if you recall, a coulomb is a huge unit of charge. There are 6.25 times 10 to the 18th charges in 1 coulomb. One fundamental charge on a proton or electron is 1.6 times 10 to the negative 19th coulombs. So if I know there's 11 coulombs per second, I can use factor labeling or dimensional analysis to convert that into hours. And so I get 3,600 seconds in 1 hour. Or you could do 60 seconds per 1 minute times 60 minutes per 1 hour, and then multiply that by 8 hours. So overall, I get 316,800 coulombs of charge will pass. That's a huge amount of charge. For PC9, it's asking about the resistance of a taser. So it's asking, or actually the resistance of a human body. Well, if a taser can cause 0.003 amps to go through the body, 1200 volts would be the voltage impressed across it. I can use Ohm's law rearranged. R equals change in or potential difference divided by current, and I get about 400,000 ohms. And that's the same order of magnitude as we've seen when we've done those experiments in class. Not with tasers, but with a multimeter. For PC10, A, B, C, and D are all asking about the amount of electric energy used in devices. So you need to recognize that a watt is a joule per second. So if we have 1500 watt hairdryer, that's 1500 joules per second, multiplied by 60 seconds per 1 minute, multiplied by 5 minutes, that's 450,000 joules. For part B, we have the same process, but it's 950 watts for 4 hours. C and D, similarly, for much longer amounts of time than 5 minutes. So I converted B, C, and D by multiplying the watts by 3,600 seconds per 1 hour times the number of hours that they were being used. And those all got me millions to tens of millions of joules. For number 11, this is also about electric energy. So Afraid of the Dark sleeps with a 7.5 watt nightlight bulb. Turns it off 8 hours later. So it's asking about the amount of energy used. So if we have 0.07075 kilowatts, that's what it would be, multiplied by 8 hours, that's 0.06 kilowatt hours per evening. If you use that for an entire year and multiply that by the cost per kilowatt hour, you get that the light bulb itself, or the nightlight, costs $2.85 per year. So I had to convert to kilowatt hours instead of just using watts or joules per second, because that's how your electric company bills you, is in kilowatt hours, which is a unit of energy. And energy is power times time. Excuse me, allergy season. So for part C, it's asking how much you would save if you converted from an incandescent bulb to an LED. Well, the LED uses 0.5 watts, so I multiply that by 8 hours per day, by 365 days per year, by 13 cents per kilowatt hour, which I should have used units for that. And the LED would only cost 19 cents per year. So you would be saving $2.66. which doesn't sound like a lot, but it's on a tiny little light. So actually, that's a big savings if you would switch all your lights out to LEDs. Number 18 is asking about the resistance of the power cables. So there's two main equations we use for electricity. P equals V times I, which is power, and V equals I times R, which is Ohm's law. Those can both be rearranged. So to solve for current, if I know the power and I know the voltage impressed or the potential difference across the lines, I can find current. So I equals P divided by V. I did not show that rearrangement here, but that ends up being 3,750 amps. Using Ohm's law and rearranging that to solve for the resistance of the wires, I get 400,000 volts divided by 3,750 amps is 107 ohms. For number 20, end up, it asks to find the resistance of a 6 ohm and 8 ohm two resistors if they're wired in series and parallel. So series, that's 14 ohms. We just add them together. Parallel, we have to add the reciprocals and then use the reciprocal again, or the inverse again, to get the total resistance, and that's 3.43 ohms. PC21 follows up with 20, asking about the current through those two circuits. So that's using Ohm's law, V divided by R in each case. And you can see much more current through the parallel circuit because its resistance is less. Going to 25, this is asking about solving through things through a series circuit. It has a bunch of different locations labeled A where you could put the ammeter, but if you remember that current is the same at all places in a series circuit, it really doesn't matter where you put the ammeter. Any one of those should give you the same reading. So the first thing to do always when figuring out things about a circuit is to get the total resistance. So I simply add these three resistors together. I get 38.3 ohms. The next thing I would do is get the total current. 60 volts divided by 38.3 ohms is 1.57 amps. That's the same everywhere. To find the voltage across 1 and 2 and 3, I would look at the current that we found out multiplied by the resistance of each resistor. And that got me 16.2, 23.9, and 20.0 volts across each of those resistors. Those should add up to about 60 volts, which they do within reasonable rounding. 29 was asking you to figure out the resistance of two resistors in parallel, so I have to add the reciprocals again, and be careful about doing that. One of the things you should notice from A and B, where I'm adding two equal resistance resistors in parallel, that's fantastic. I will pause. Hold on. Hello.
Hi, Doug.
How are you?
I'm okay. Happy Sunday morning.
Happy Sunday morning. You sound only okay. Aw. Is it nice down there?
Rain here.
You're
Raining. There's no bike ride going on this morning, but maybe this afternoon. We'll see.
okay.
I needed a morning of rest.
Well, I understand that.